Okay, so I'm just going to get started here in a couple minutes. I've got 20 minutes to talk about WinDbg, which is a super easy task for all of you that know about WinDbg. But just while we still wait the last minutes before I start, I just want to get like a gauge of who's here. So how many people have used WinDbg before? Okay, how many people like it? Great audience. Okay, how many of you are like C# managed code, high-level user mode stuff? How about low-level kernel mode, somewhere in the middle, like C, C++, native apps? Okay, cool. So good mix, but no one likes me. That's great. And then how many of you use WinDbg Preview? So those of you put your hand up, WinDbg Preview. How many of you haven't even heard of it? Oh, cool. So I'll make some of you happy at least. I have stickers, by the way. I'll be hanging out right over here afterwards if you want to grab one. And then I will be over in the meetup area at 2 o'clock today and at 2 o'clock on Wednesday, talking more about debugging. Anything you want to talk about WinDbg, time travel debugging that I'm talking about today, I'll be over there. So I'm just going to get started because I'm already pressed for time by this. I'm going to be basically doing a bit of a lightning style talk here. I'm going to be going through a bunch of the features that we've added in WinDbg Preview. I'm going to be scratching the surface a little bit on some of the more powerful features that we've added and released recently, including time travel debugging. So if you haven't heard of that, it's a pretty fantastic technology to use. So for those of you that aren't too familiar with WinDbg, it is a pretty intimidating tool. I already heard people talking about how it's some type of power user tool that's really hard to use. When you install it, you're like, did I get the Windows XP installer, or is this, what am I doing here? So a couple years back, we released WinDbg Preview. It's a little bit more modern. We're trying to make it a little bit more familiar with those of you that use Visual Studio. And it's basically just a visual refresh over a lot of things. Those of you that are familiar with WinDbg, all the commands you normally use, it's the same exact engine underneath, so all of that still works. I'm going to do like I said, kind of a lightning talk about kind of the high-level new features, and then I'm going to dive deep into a couple demos. So first up, when you start debugging, today you hit File, Attach, and then you get a weird dialog that's ordered by like PID, which is nothing that anyone ever actually knows what to do with. So we've got easier to figure out what you're doing. Those of you doing universal apps, you can launch your universal app straight from the debugger. You don't have to go through PLM debug or any of those old tools. Attaching is better. Connecting to remotes is easier. We've kind of done a full refresh there. I'm just going to put the next slide up and not have to say anything. It's a dark theme. That's been one of the biggest features that everyone's loved because developers love dark themes. Better windows. So the source window in WinDbg has always been kind of awful. The disassembly window doesn't scroll right. The memory window is a little weird. We've refreshed kind of all of them. So source window, we're using the same editor as VS Code. So you're going to see it's going to be super familiar. Disassembly window, we've done a lot of just general features for that to make it easier. A lot of people that use it have to dive into disassembly. Things like when it shows you hexadecimal, you can hover over it. It's going to show you the decimal. Locals window integrates NatVis files, same thing that Visual Studio has. So if you're looking at a linked list, it shows you the list and not the internal implementation details of a list. On the more controversial front, the customizable ribbon. So we went with the ribbon because the menus are very difficult to navigate in WinDbg. There's a lot of things there. For those of you that really like your vertical space, that feel like the ribbon really attacks that, you can collapse it down and you can pin things to quick access. In this collapsed state, it's actually smaller than WinDbg and Visual Studio. So you have more vertical space. If you collapse it down, you can easily get to the things you want. And you can get to know those icons better, and you can customize it. So if there's buttons that are important to you that aren't on there, you can add them. If there's buttons that aren't important to you, you can get rid of them. Built-in scripting. So those of you that said you weren't familiar with WinDbg Preview, you might not be aware that we have JavaScript support right now. So you can just very easily write a JavaScript script, run it through the debugger. This is really useful for automating the debugger as well as extending it, which is something I'll get into shortly. And finally, the kind of biggest feature that we've added to it is called time travel debugging. Time travel debugging lets you record the entire execution of your process. This is user mode only. Sorry, the people who raised your hand for kernel mode. You can record the entire execution of your process, replay it forwards and backwards, and query across it. I have a demo for that in like a couple minutes. and much, much more. So we've gone through pretty much every experience in WinDbg and revamped it a little bit. We're actively working on it. I will say it's only installable through the store right now. That lets us really get out updates real quick. We just had one last Thursday. We released a big update. So go on, try it out. But let's get into a couple demos. So the first thing I'm going to talk about is what we call the debugger data model. It's normally accessed through the dx command. So those of you familiar with WinDbg, you try and dump out like a standard list. And WinDbg generally cares about the real implementation details of a list, and you get my pair or something similar. And it's not really what you want. You want your code that you're debugging. So we have this shared concept with Visual Studio called NatViz, where we have NatViz files that come in the debugger already loaded, where you can actually see your list. Really revolutionary. But we also have link queries on top of those. So those of you familiar with link, L-I-N-Q, link, you can actually search across your structure. If you have a very long list, you can search for certain elements. You can order it. You can do basically the entirety of what you can do in link. And this is all extensible. So while I said this is NatViz, you can write an extension in JavaScript, or you can write an extension in C or C++. I have links at the end to how to do that. We have a bunch of tutorials online. We have videos going deep into each of these topics that you can walk through. And we have a GitHub that has a bunch of samples. So if you're really interested in this, I have a link at the end. In addition to native types and visualizing those, we have kind of a central knowledge, or a central database kind of, to store everything that you have that's important. So over here I have the lm command, which those of you who have a bunch of commands memorized know that list loaded modules. And if you want to get the specific information on a single module, you need to do lmv and then the module name. There's a ton of concepts in WinDbg that make it really difficult to approach and that we're trying to get rid of. So if you look here, I have dx curprocess.modules. All of this is browsable. I'll hit it in my demo in a second. But this lists all my modules. I can click into one of those modules and it goes. And all of this is extensible. So you will see, again, I have a JavaScript extension that I will show you in a second that says, for every module, attach information to this so that when I'm looking at it, I can query across it. I can do link queries, or I can script across it with JavaScript. So I'm actually going way faster than I needed to, so that's great. Is that me? No? OK, cool. I can't really hear it from up here. So let's hop into my first demo. So over here, I've got a kernel dump loaded. This is a very kind of bare bones layout for right now. I wanted to make sure I had enough space for people to see things. So on the left there, I have what's called the data model window. And it lets me pretty easily go through and browse what I have here. So I have a debugger session. It's a kernel dump. I can click through. I can see processes. I can see attributes of it. Here's every process that was running during this dump. I can click into a process, and I can see the threads, the modules. All of this is super easy and browsable. For those of you who really like commands, I can come in here, and I can type. I can drop my mouse. I can type dx. Oh, no. Minor technical. OK, good. I can come in here. I can type dx debugger, and I can do the same thing I was just saying. I can start clicking through in the same way I was doing that before. I can come in here. I can look at all my modules. When I go into a module, you see here this. I've got 4 attributes on this module. The base address, the name, and the size are added by a C, C++ extension in the debugger. Where you see contents here is actually added by a JavaScript extension. This is an extension I didn't have to load. I didn't have to run bang LMI to list module information. I just had to click it. And what I can do across some of this data, so let's say I'm looking at this dump, and we have some aliases here to make things easier. So cur session, cur process, cur thread, all of this is in the links at the end of this, so don't worry about it. I'm going to look at all the processes of my current session. So this is all the processes in my dump. But what I can do is I can write a link on top of this. So for those of you familiar, I can select processes, and let's just put out the name of the process. So I just printed out the name of my process. But let's say we want to do a little bit more. We care about the name, but we also care about the thread count. We've got there's a bunch of processes loaded here. I don't know what's doing what. And I can put thread count is the threads, which was a thing I just browsed to. And let's see if that actually worked the first time. That's not really that useful. So I can actually come in here. I can spit it out in a grid. So -G, we're getting back into, there's some things you need to learn about WinDbg. But here I have the list of every process and their thread count. So I can come through here. If I'm interested in one, I can click into it, and I get the information about it. This is kind of a real quick example, not super useful in this case, but as you can kind of see, it can extract out a little bit. You can kind of query across all the data that we have. Going back into kind of one of my going back to one of my modules, let's pick that one. Not modules, process. All that was tab complete, by the way. I didn't mention that. I can tab complete. It tabs through all the available fields. So I'm going to hop into one of these processes. And like I was mentioning around that native type visualization, I have environment here where I have an environment block, and you can kind of see it's a type peb. And I can very easily click it, and I can jump to my peb. If you have a type in your application, a globe or something that's fairly complex, you can do something very similar to that. That was kind of an awful example to click, though. OK, so I will hop back over here. You heard me mention JavaScript. You heard me mention C++. Just a quick example of one of those extensions. This is a snippet of a JavaScript extension and a C++ extension. I have a lot of people, especially WinDbg users, who tend to not be the most JavaScript-friendly folks, tell me, oh no, JavaScript, I want native code. So this is an example of adding the file description from a binary onto the data model for modules. C++ is like 3 or 4 times the amount of code. JavaScript is super quick and easy. And if you look at this real quick, it's some if statements, it's some strings. It's really not that complicated of a process. You don't need to be a JavaScript expert to do it. I wrote it, and I'm not that good at this. So again, I have examples of this all online. Next up, time travel debugging. So quick poll in the room, time travel debugging. Who's heard of this? OK, a few hands. So what time travel debugging is, or it's sometimes called reverse debugging. Normally when you debug, there's kind of 2 different ways people debug mostly. A lot of people do this printf debugging, which is great, really efficient. You add print statements until things work. Everyone's familiar with that one, I'm sure. Or kind of normal debugging. You set a breakpoint, you run your code, you either have to kind of hit go, run past it, restart, you kind of have that reckless approach, or you can kind of step slowly and meticulously till you think you figured out your bug, restart a few times and do it. Reverse debugging or time travel debugging, you have a trace of your execution of your process. You can run past your problem or straight to your problem, and then you can just step backwards until it looks good, and you can kind of very quickly go back and forth. You can do kind of a binary search across your, the execution of your process. More recently, and kind of only in our time travel debugging solution, is queries. So like I was showing you that link query where I could select certain things from my process list, I can search across my trace execution. So I can find all the function calls to this function that returned a certain value. Or I can find all the heap allocations. I can find a use after free just by looking for all of the times I used something after I freed it. It's all very super quick, easy. It's more searching than it is for setting breakpoints and running back and forth. So I'm going to find kind of the same bug in a process using both reverse debugging and queries. So for those of you who aren't super familiar with C and C++, I really wanted to pick a very simple example. So this is our get build greeting. We're going to say hello from the WinDbg team. Good luck in all your time travel debugging. But when I run it, I get an exception of some sort. It's an access violation. This isn't a super realistic example. I don't need time travel debugging to fix this one. You might be able to find it just by looking at the code. But think more how this can apply to something that you might have hit in the past. So I've got a slightly different WinDbg setup over here. I apologize for the memory window on the side. We have a text scaling bug, so I wasn't actually able to get it to scale right. So when you open a time travel, so first when you record a time travel debugging trace, actually, you're going to, It's really easy to do. I'm not actually going to demo it because it does slow down the execution of your process. We're recording everything you're doing. But when you attach to a process or launch it, you're going to have this little record process with time travel debugging checkbox. It does require elevation. You're going to check the box. It's going to launch or attach. You go through your repro, you stop it, and it's going to open up the trace. The trace can be used later, so you can save that repro as long as you want. You can send it to your colleague if you find out it's their code and not yours, and they're the one who's supposed to look at it. Super convenient. So here I've got a trace. I know it hits an access violation, and I know WinDbg is going to break in when I hit it. So I'm just going to hit go. As I go, I've broken in. It says there's an access violation right here. So I'm going to actually highlight a little WinDbg feature right now. I'm going to hit Control-Alt-H, and it actually highlights the word access violation. If anything else prints access violation, it's going to highlight that for me. I'm going to Control-Double-Click over here on the code. That also highlights it. And then I'm just going to actually take all this information right here, and I'm going to throw it over into my notes window. The notes window also has this highlighting, so I can highlight anything across there. Something interesting to me is going to be this link. So all of the DML links is what we call them that spit out in the command window. If I click this here, it's actually going to run it. So that's one really nice thing about the notes window in WinDbg Preview. But let's get into this bug. So the first thing I notice here is my stack pointer. It's not resolving right. If you look over here at ESP and EBP, they're a little bit off. So I have a feeling that there's something up with the stack frame, especially since there's an access violation. I probably wrote over what was necessary. So I'm going to jump my memory window. Oh, I already did. Didn't really mean to reset that. To the location of the stack pointer. And you might have to trust me unless you have really good eyes. What we see there is the string that we're actually trying to print out is for some reason on my stack pointer. That's not really what I want there. I have an overflow somewhere where I shouldn't be hitting that. So I'm going to do a normal WinDbg thing. I'm going to set a memory access breakpoint. So BA is what that is. W4 means if I write within 4 bytes of that, and I'm going to set it on that address for my stack pointer. So normally when I would run forward, I would hit this next time something writes to that. But what I'm going to do is I'm going to run backwards. So this is going to take me back to the last thing that wrote to the stack pointer, which should be not me. It should be something more in the OS level. And if you look here, it's my getBuildGreeting function called by main. I'm assuming it's not a UCRT bug. I'm not really good enough to break the UCRT. And if I hit here, it's getBuildGreeting. A little bit of looking at this, and you can see that I have a 50-character array, and I have way more than 50 characters. So it looks like as I'm calling that string copy, I'm overflowing a little bit. I probably need a bigger array there to stop that from happening. Again, super easy bug. Most people could look at the string I had there and say, yeah, that's more than 50 characters. Your array's too small. But this is just kind of a quick example of how that could be used. So personally, I don't like breakpoints that much. I don't like stepping backward and forward and figuring out where I am. So I'm going to kind of show you the other way of doing time travel debugging. So I'm going to clear my screen. I'm going to do bang TT, which is a command to just change the position of the trace. I'm going to go back to the start. And I'm going to use that same DX command I was using earlier. I'm going to click through into a session, and you see it's time travel debugging. And you can see here there's actually a new object here that is a TTD object. So this is added by the TTD extension. I don't really want something at a session level. I want it at a process level. There's also a TTD object here. And all this is documented, by the way. I happen to know this. You can browse through it and stumble upon it, but we have documents saying, here's where things are located. So I'm going to go to events. This is basically a list of everything that's happened in your trace. Earlier, I highlighted that exception code. So I have an exception that hit here. If you had like 1,000 exceptions, you might need to query across these events. So you can do, find all the exceptions where the exception code is this. In this case, I have 1. So I'm going to hit that. And it looks like it's the exact same one. And I can hit time travel. So this has now jumped me to, if you remember the stack before, this is my corrupted stack. That's not that great. That jumped me to that event that happened. And then now I'm going to write another query. This one is all handwritten, so I don't really have an easy way of browsing to it. I'm going to look at the current session. We have the ability to query across memory. So I can query memory reads and writes. You remember I said a breakpoint on writing memory. I can do the same thing here, but across the entire trace without having to run back and forth if I was writing to the memory a lot. So hopefully I have that copied still. So I have to manually add those 4 bytes I had, which was 78. And I'm going to set it right. So all of this is super documented online. So I'm doing a memory query from that memory range for write memory. I already saw a typo. And then for the sake of time, I need to do an order by because I want to make sure that I get the last one that was written. And I happen to know off the top of my head that there is a time end field that specifies when the memory write started, when the memory write end. So I hit enter here. This is every time I access that memory. And if I come over here and find my mouse, I can scroll over a little bit, and I can go to this time end. Oh, wait, no, right there. So this is the description of the memory access, and I can time travel to where it was. And if you look at my stack, I'm in the same location. So this is 2 ways of getting to the same kind of minor, could have found it in a better way bug. But if you imagine, you can do much more complex queries. You can stack these queries on top of each other. They're extremely powerful, and Microsoft has been using this kind of across the board in a lot of our support cases and test and lab automation cases recently. So this was my bug. So kind of my last goodbye. Thinking with queries is something that's really powerful. It is an extremely different mindset than normal debugging. So you really need to think about actively using it and not just falling into the trap of normal debugging. So I definitely encourage everyone to try it. You can query across things like notable events, find out when modules are loaded or unloaded, threads are started, find exceptions, function calls, find every time your function returns a value that you don't expect is always useful. Memory reads and writes, I just showed that for you. Heap calls is super useful for finding things like use after freeze or double freeze. You can see the same heap call every time it's used. And then thread lifetimes, being able to search across the start and end of a thread's lifetime. So if you want to learn more about this, here's that link I mentioned, aka.ms/WinDbg basics. This basically has like a nicely formatted table of where to learn more about all of this. We've done detailed videos on every single one of the subjects I touched today. I was only able to scratch the surface a little bit. Today and Wednesday, I will be over at the meetup area. It's kind of over by the entrance over there, talking about WinDbg a little bit. If you have any questions, thoughts, concerns, I love listening. If you can't make that time and want to just say hi to me, you can tweet me at alures13 on Twitter. I'm going to be wandering around today and Wednesday pretty much all day. I have WinDbg stickers. I will be over here afterwards. Feel free to come by and say hi. Thank you so much for stopping by.